So hello all. So in this video we'll learn about traversal of depth first search, that is DFS, one of the topics which comes under the tree data structure. So depth first search, basically it is implemented with the stack data structure. Okay, so it is implemented with the stack data structure. So in the BFS is implemented with the queue, whereas in the DFS it is implemented with the stack data structure. Okay, so in this DFS you can take root node as any node, like you can take 0 or 1, any node you can take it as a root node. See, for example, if I put it in the stack, so see, this is the result you think. Wait for a minute. This is the result. Okay, so here see all of you, for example I am pushing the 0 to inside the stack. Okay, so inside the stack I am pushing, so I will take the 0. So for 0 in the BFS, what we have done, what are the adjacent vertices are there, whichever adjacent vertices are there we were taking. But here what you should do, any one adjacent vertices you should take. Okay, for 0 which are the adjacent vertices, one is 1 and one is 3. So I will take any one of the adjacent vertices. For example, I will take 1. Okay, and I will write down here. And for 1, which are the adjacent vertices are there, one is 5, 2 and 6. So in this 2, 5 and 6 you can take any one of the adjacent vertices. For example, I will take 2. So I will write down here 2. Okay, after 2. After 2, for 2 which are the adjacent vertices are there, one is 3, 1, 5 and 4 are there. Any one you take. I will take for example 3. Okay, so I will write down here 3. So for 3, which are the adjacent vertices for 3? 0, 4 and 2. 0 is already in the stack. 2 is also already in the stack. So which is not there in the stack, that is 4. You will write 4. Okay. Now we'll come for the 4. Now we'll write down here 4. And for the 4, which are the adjacent vertices? 2, 3 and 6. Right. Any one you should take. 2 and 3 is already inside the stack. Any one you take means you will take 6. Okay. I will take 6. And I will put it here 6. But for 6, adjacent vertices are 4 and 1. But 4 and 1 is already there in the stack. So what you should do for 6, nothing is there in order to put it into the stack, because 1 and 4 are already there. In this case, if this situation arises, what you have to do means you have to initially pop it out. The element you should instantly remove. Okay. For example, 6 I am removing. 6 I will pop it out. Okay. I am popping out 6. Sorry. Yeah. I am popping out 6 now. So for next you will check for the 4. For 4, which are the adjacent vertices? 3, 2 and 6. 3, 2 and 6 we already have written. So it's already there in the stack. 6 is already visited and 2 and 3 is also visited. So we will remove. Okay. So 4 also we are removing. Okay. Next we'll come for the 3. For 3, which are the adjacent vertices? 0, 2 and 4. It's already visited. 0, 2 and 4. That also we will pop it out. See, which are visited, no need to write. Which adjacent vertices is not visited, only you have to put it in the stack. Okay. Now, next one is 2. For 2, which are the adjacent vertices? 1, 5, 4, 3. 1, 3, 4 is already visited. So 5 is not visited. So what you have to do, you have to put inside the stack. Okay. And you will write the 5 here. It's already visited. So now what you have to do, you have to pop it out. Now we have to pop. Why you have to pop it at 5 means, see, because for the 5, which are the adjacent vertices? 1 and 2. Right. 1 and 2 is already visited. 1 and 2 is already visited. So what you have to do, there is no other vertices which is not visited. It's already visited. So you have to pop it out now. So you have to pop it out. You have to pop it out. Okay, 5 you will pop it out. Next you will come for the 2. For 2, which are the adjacent vertices? 1, 3, 4, 5, yeah, 1, 3, 4, 5 all are visited, you will pop it. Next you will see for the 1 which are the adjacent vertices 2, 5 and 6. 2, 5 and 6 is also visited, erase it. Now 0 which are the vertices 1 and 3, it's already visited. So you will erase this also. So now what is that? Now the stack is empty. So now the stack is empty and this is the traversal of the BSS. The result is the traversal of the BSS. This is the traversal of, sorry, not BFS, DFS. This is the result of the DFS. So this is only not the final answer I can tell. I mean, not the final answer means this is only not one answer you will get. If you take adjacent vertices for 0, if you take 3 means the order will change. So for DFS, what adjacent vertices you are taking, it matters. But whereas in the BFS, all the adjacent vertices you are taking, it doesn't matter. But in DFS, each one will get an unique answer. Since adjacent vertices here, you should consider only 1. If there is a 3 means you will consider only 1. In such a way that I got this traverse. Thanks for watching. Do like, share and subscribe.